Welcome back to our final session of the day. Our first presenter in a session of 2 talks followed by a conversation is Holly Andersen. Holly.
Thank you. All right, am I close enough to the mic? Okay. All right, so foundations of causation. I got to talk, oops, it's cutting off the top of my slides. I did at least have one person who was honest enough to say, oh no, there's going to be a talk on causation and kind of eye roll, and I promise you that there will not be any equations in this talk whatsoever. And there also won't be any presupposition that you know anything about any of the theories of causation. So I'm going to do something that's much more kind of big picture. Do we need to fix that?
How much is cutting off?
Actually, a fairly substantial amount. Can you see that? Oh yeah, it's just for the intro.
So it looks like the rest are okay. It's this, just this slide.
It's just this slide.
Okay.
Okay. All right, just this slide. So mostly what I'm going to do is give a kind of overview of where I think we are in the present on something that I think is really exciting. And I'm going to be kind of drawing on a sort of integrated history and philosophy of science methodology. So I think a lot of work, for example, by Ha-Seok Chang in 2007 in Inventing Temperature, and also in his most recent book on pragmatism, Realism for Realistic People, has a lot of really useful sort of methodological work that we can use to think about this. In particular, we can look at the ways in which some of these discussions are both very historically and socially situated and in ways that affect the content of it, while also being still norm evaluatable and susceptible to understandings of progress. So I think we often come into this with the idea that either it's situated or it's subject to norms, but not both. And so I'm going to do, no, both. We can have both of these. So what I want to talk about is this idea of foundations as a kind of package that includes metaphysics and epistemology in this sort of mutually constraining way. So I'm going to be giving a kind of, I don't know, sales pitch in some sense for a kind of coherentist, non-reductive, pragmatist metaphysics. And I think for a lot of philosophers of science, this is going to be a nice alternative to what I'm now calling kind of post-Lewisian metaphysics, which has a very different way of doing it. Sometimes we call it analytic metaphysics, but I think this is kind of a propaganda move by Bertrand Russell, so I've decided, no, we should talk about it as post-Lewisian instead. So I'm essentially going to go through a kind of historical comparison and look at the different ways in which certain fields have branched out of natural philosophy, because I think there's some interesting historical comparisons that we can get there. I'm then going to move to talk about causation in philosophy and in the process of leaving philosophy. So that takes us up to the present moment. I'm then going to talk about foundations without foundationalism for causation, because I think we're literally in the middle of probably a 40 to 50 year process of this branching out right now. And what I think some of the next steps could be for this sort of iterative refinement, especially a sort of conceptual articulation for causation as a science. All right, so natural philosophy, I thought this was going to be a harder sell, but after Lydia Patton's talk yesterday, maybe this will be an easier sell, has been generating new fields of what we now call science, at least since the early modern era. So I spent some time thinking about the Newtonian case over the summer. And there's a couple striking things that I want to point out about this. So I'm not going to tell you much about it other than highlighting what I think are some of the takeaway points. So part of it is that it's a time-extended branching off. So even when you have someone like Newton who's publishing his works, then it took a while to get there, and then it took a while afterwards for people to sort of, in particular, people like Du Châtelet and Lagrange really had to work to put this together into a more coherent fashion. So it wasn't that there was any particular publication that at the time that it occurred ended up being the central thing that made it happen, like, okay, now we have mechanics. And there's a way in which Newtonian mechanics is a good place to start because it's literally the paradigm of a first paradigm. So if you read Kuhn, then a lot of what he uses as the examples to establish what is it to have, you know, the establishment of a first paradigm draws on this particular case from mechanics. And then there's a few things that are sort of crucial to what happened in this branching out. One is that we had to develop new representational tools that were more adequate to the task. Part of it had to do with conceptual articulation and especially differentiation and refinement. So there was a way in which we just didn't have enough in terms of conceptual resources. And so when you read some of the early stuff, even when you're reading, my degree was in physics, and then you go back and you read Newton, and it's really confusing because you can't figure out what he's talking about with some of this vis viva stuff. And it turns out really what we needed was, in conjunction with different ways of using the mathematical resources, to differentiate among things like acceleration, or kinetic energy, or momentum. So we weren't able to really divide those apart and talk about them until we did some more cleanup work afterwards. And one of the important things that worked, I think, was bracketing some of the metaphysical issues. So yes, it would be really lovely to know how to solve this, but we don't have to solve it right now. We can still, we can put it there, and in the meantime say things like hypotheses non-fingo, and then keep going. And so part of what was involved, and this was the looking at Emily de Châtelet part, is finding this established basis of agreement among people who were otherwise having this metaphysical dispute, and doing so in a kind of introductory textbook form so that people who wanted to learn about it could start with that sort of shared set of common assumptions. And those were the things that all of the practitioners, so if you were a Leibnizian or a Cartesian or Newtonian, then you could still get on board with this sort of shared set of assumptions. Whereas prior to this, they'd been sort of emphasizing the differences among their different views, because they were more hung up on the metaphysical part. All right, so geology also is an interesting comparison case here. Part of what was happening in, I think, the sort of the middle of the 19th century was that trying to establish yourself by this point in time as a science meant that you had to differentiate by showing that you were more like physics, in particular like mechanics. So this was now what they were taking to also be sort of the paradigm of what it meant to be a science. And so what happened in their branching out as a new field was sort of different. They were trying to differentiate from being sort of narrative or historical in character. And so it wasn't just, geology isn't just one thing happened and then another and then another. They had to establish that there was this distinctive subject matter that was not entirely contingent. They also had to establish that they had distinctive methods of inference that were in fact more like the sciences, and in this case, physics, the new physics, rather than being like those that were in history or even in theology. So they weren't like a narrative, they were more like this. They also had to discuss explanations, including the fact that they could offer lawful generalizations. And so when you have disputes about like catastrophism and uniformitarianism, there's a way in which they were able to situate these as already within the science itself, I think, because they were disagreeing not about what kinds of explanations they were going to give, but what kinds of causal relata were allowed to be inside those explanations. All right, so they already had enough shared assumptions about their foundations in place that they could then move on to which of these causes are allowed. And this is a case I know a bit more about. So in psychology, I think we have an especially good case of a new science branching out of what was previously done under the heading of philosophy. So William James in the Principles of Psychology, if you compare the abridged and the unabridged version of Principles of Psychology, it's really illuminating, I think, because the unabridged version is really for really for philosophers, and the abridged version is really now for psychologists, and it's much more like a textbook for psychologists. Namely, I've now stripped away all of the disputes that were more kind of philosophical in character, and I'm just giving you the part that we sort of feel more confident about. And if you look at the chapter headings in especially the unabridged version of Principles of Psychology, there's this lovely continuity that you get with people like Thomas Reid, and then, let's see who else. Oh, we've got Dugald Stewart and Thomas Brown, William Hamilton, then William James, and he's in this tradition where everybody has very similar sort of faculty psychology chapter headings. And then you sort of criticize the person who came right before you by adding a little chapter. So at a certain point in time, we went from sensation to having two chapters, sensation and perception. And then we went from having a chapter on memory to having two different chapters on memory. And so when you look at James, he really fits nicely at the end of that trajectory, even while being somebody who's now branching us off into a different kind of way of approaching this so that it's no longer within philosophy. All right, so crucial to this branching out, there was a lot of German psychologists who were already doing experimental work under this, and William James ended up being central because he was coordinating with several very, very different groups of people who were not necessarily coordinating with each other. So he served as a kind of hub of a sort of professional, personal network where he's incorporating different views together that hadn't otherwise been talking to each other. This includes some of the empiricist work in Britain, such as Shadworth Hodgson, but it also includes sort of new American empiricist work, such as Peirce. So with this, we also see sort of the establishment of a textbook, and we see a kind of descriptive approach to consciousness. So he sets aside a lot of the metaphysical questions, and he's like, well, really, we don't know what it is, but here's 5 distinctive features that it has, and then we can just study those features and talk about this. All right, so there's a lot of ways in which what I'm calling natural philosophy has been sort of like branching out these new fields over time in the last centuries. This isn't a universal trajectory, though. So sometimes there are fields or subfields that had roots in philosophy, but they kind of took a different path, where they didn't just straightforwardly branch out in the same way. So I think that there are interesting cases in thermodynamics. In particular, there were people who wanted to present their work to the Royal Society, but had some gambling debts, and so instead had... Actually, I have co-authored work on this that I'm working on with somebody at UBC, actually, Kelsey Vickers. We looked into this, and so the reason they had, so he owed these gambling debts, and then this guy was like, no, I'm calling in my gambling debts, and so we're gonna patent what you just did, because there was so much money to be made in showing that your trains were more efficient at converting fuel into like forward motion of the trains. And the reason the trains were so much a source of money was because this was really when you were getting going on the British colonial project of putting trains across North America. And so there's this really interesting sort of side story about why there was so much money to be made in having parts of thermodynamics be developed in this private fashion. But I think there's also parallels to that now. So, and I think this is relevant to some of the causation stuff that I'll say later on. A lot of the stuff on pattern recognition and machine learning, a lot of stuff in pharmaceutical research and genetics, there's a lot of different examples here. Anything where there's a lot of money that you could clearly make now is not taking this same kind of path that I just described. So nobody had figured out how to monetize William James yet. So in these cases, you have something that's much more private and not disclosed, and this really shapes the way in which the work takes place. And I just included this quote by Dewey because I thought it was lovely, and he thinks that true science is distinctively the study of useless things, for useful things will get studied without the aid of scientific men. So they will get studied because you make a lot of money on them. All right, so I think that causation is right now in the process of branching out of natural philosophy. So I think it's now branching out of what we now call philosophy of science, but I think that these discussions predate the existence of philosophy of science. So I think that in that sense, it's more apt to sort of give credit to natural philosophy and philosophy of science as one of the sort of continuations of the tradition of natural philosophy. All right, so then what we're gonna cover in the next 2 sections, why should we think that there's the establishment of a first paradigm that's happening right now? What distinctive features does this have? And where are we in this process? Oops. Okay, so this is going to be a really super short potted history where I'm only gonna pick out a few highlighted things, not because it's the most accurate way to tell the historical story, but because these are the things that I wanna be able to talk about later on when we get to the second part of the talk. And I think that part of what's really important is that when we get to, say, the middle to the end of the 19th century, there was this ongoing clarification that was just getting started about how we should use certain kinds of terms. So I have some examples from Whewell, and I wasn't able to find it while I was looking for the Poincaré, but Whewell and Poincaré were in different places using the terms cause and laws in exactly the opposite way. So one of them was using laws for what you could merely see right there, the sort of descriptions of regularities, and then causes would be the explanations underneath, whereas the other was using it in the opposite fashion. And so there really was no agreement about what it was that we were talking about when we were talking about causes. So this discussion goes back a long way. I mean, we could have started with Aristotle, but at this point in time, we're really starting to get more specific about what it is that we want to be doing with laws and with mathematics in physics. All right. Yeah. The explanatory springs. Adding into this is a long discussion that came out of the medieval era, especially with the principle of sufficient reason. And this was an explanatory principle that stipulated that there was some kind of thing that really differed depending on the author that you were reading, that could have been a cause, or it could have been a reason in a more loaded notion of reason than just a mere cause. So like, what is the reason why this was the world that God chose instead of some other reason? So there has to be reasoning that goes along with it. Or grounds, like what are the grounds for something to be taking place that in all of these cases sort of suffices to explain its occurrence. So we have this really sort of closely connected set of terms involving causes, there's powers, there's laws, there's reasons, there's grounds, and there's explanation that sort of come out of this period in this really sort of clustered, confused thing. So we have this lack of clarity when we hit the 20th century, for example, about the role of causation versus laws, about causes as explanation, as sort of equivalent to or definitionally the same as explanation, in the sense of providing information or providing understanding. We have causes versus reasons for why something happened, and actions and causes. So we have this sort of built-in, almost teleological part that it's been carrying with it. So there's this baggage that comes with the PSR that seems to be very teleological. And sometimes we get this idea that was in the Whewell quote, that causes are this deterministic glue that sort of stick together the slices of time. And so if you were sort of an occasionalist, then it might have been God that did the work of making sure that whatever happened in this slice, the next thing happened in the right kind of way to line up. But when you get rid of God, then you might have something like causes. But you also have this idea that causes are sort of oomphy and physical. They're like the springs that might be hidden, or maybe you can get to them, but they're sort of doing something more, yeah, oomphy here is like a technical term. Yeah, we'll just stick with that. It's conveying necessity, and the necessity is built into the world, is part of what comes with it. And there was this deep skepticism of causation as going beyond the directly observable. So from Hume onwards, we had this idea that causation is not properly empirical. Really, it's what we're adding or projecting onto the world, because you can't really see causation. You just see constant conjunction or something like this. So we come into the 20th century with this, like, you know, there's something spooky, there's something teleological, we're a little bit suspicious of it. So there's a couple of key things that happened in the early 20th century that sort of damned causation. And here, there's a really great paper by Nancy Cartwright on this that says some of these things too. In particular, we have Russell's 1912 on the notion of cause. He really thought that he was showing that you could get rid of causation because the word cause doesn't show up in physics. And instead, you could just use functional equations. And I've always found this very frustrating because he didn't actually know any of this physics that was, I mean, like 1905 was the year that a lot of important things initially started happening, but none of that had been sort of absorbed by him. So he's really working with a sort of old-fashioned Newtonianism. More what he was rejecting was this kind of like PSR plus teleological explanation involving reasons. And he also was making this point, okay, we don't use the word cause in physics, but he didn't address the fact that there's all of this sort of causally laden terminology that was in there. All right. And I think we actually ended up with a similar problem from McTaggart. So even though McTaggart was writing on time, the way in which he was conceiving of the world as this sort of, you can almost think of it as like banana bread, and you're only allowed to slice it this way, and then you have to stick your slices together, and then I make lots of cake analogies when I teach this to my students. But together, the two of them really shift the discussion so that any substantive notion of change over time is kind of off the table and considered unscientific. So this brings us then to the middle of the century. We've got Hempel and Oppenheim's deductive nomological model. And part of what they do is take this idea of necessity, and it's no longer in the world, but now it's in the logical relationships between premises and a conclusion. So you've gotten necessity back, but you've gotten it in a very different form than it used to be there. And laws are these special kinds of true universally quantified statements. And in particular, causation now turns into causal laws where they are the deterministic ones. So if a covering law is properly deterministic, then it's called a causal law. And so you make causation and explanation interchangeable. So causal laws just are those that could serve in a deduction, whereas the other ones can merely serve in an induction. All right. And there's a lot of issues that this sort of brings into philosophy of science. It leaves this big gap, but part of what's interesting is the second part of their paper really goes on about teleology for a long time. Like there was still this real sensitivity that they had about, are we doing something spooky when we use the word causal? And then they had to sort of defend themselves against this, this charge. All right, so meanwhile, there's some really interesting connections that come in again with time and causation. And why don't we throw in some more arrows? There's something about action that lets us, change the future, we think, and not the past. We have agency that seems to have a teleological element to it. And in particular, we introduce thermodynamics and entropy. So there's this idea that there's all of these different arrows that we're now going to talk about. But he also introduces this sort of way of representing cause and effect and starts us down a path where, oops, that was the... There we go. We're now going to start treating explanation in terms of probabilities. And we're going to do a lot of things with probabilities, and I'm just going to sort of skip over most of that. Because mostly what we found is that it was never adequate to what we needed to do. So there was a lot of fiddling with it and trying to improve it and make it better and better and better, but it was never going to be enough to cover the cases that we needed to be able to distinguish between all of the counterexamples that clever people could come up with about correlation versus what we thought was really going on. You're not allowed to use the word causation yet. So two really important things happen then. One is Nancy Cartwright's causal laws and effective strategies. She's like, look, of these causal laws, some of them are deterministic, but some of them you can use to actually change things. So if you don't want to die earlier, then you shouldn't buy a TIA-CREF life insurance policy because that just isn't an effective strategy. So she has causation as this extra ingredient that's on top of whatever it was that were the causal laws. And there's also this really, I think lots of people should read this. It's especially chapter 2 in Georg Henrik von Richte's Explanation and Understanding. And he has a really long discussion about causality and action, and essentially says, look, causality is what we do because if you just observe the world, it would never take all of the values that it could. You have to sort of reach in and make it do things that it wouldn't otherwise do. And in order to do that, you always have to be standing outside the system that you're reaching into. And so he had this idea that you needed causality to be, in some sense, a proper subset of what was going on in the universe. It was no longer like this full deterministic thing. There has to be a space there. This is my two rivers that don't mix, and then they split right around David Lewis. And so I think there's a real divide where the treatment that we get of possible worlds, even if you're not a realist about them, and sort of Lewis-Stallnacher counterfactuals, were deeply resisted by a lot of people in the other stream, namely in philosophy of science. So this occasioned a big backlash, and Wes Salmon's positive sort of process account was entirely predicated on we shouldn't have to ever talk about those counterfactuals. And so he has a lot of stuff about counterfactuals being awful, but it's important to note he's not talking about interventionist counterfactuals, he's really talking about these kind of like Lewisian counterfactuals. They're very different than the sort of stuff that Nancy Cartwright was talking about or that von Richt were talking about. All right, so we then have this sort of divide where there's the counterfactual difference-making stuff and this like oomphy physical stuff over here. And then in 2000, big things happened. And this was kind of fun to listen to Anna Alexandrova, because I went to the London School of Economics in 2000 for my master's. And then I met her in 2003 at my first professional conference, and then we got to talk about how influenced we were by Nancy Cartwright while we were at the LSE. And I wasn't in Causation yet, but it was really fun to sort of look back and realize how much I was sort of in the room while a bunch of this stuff was happening. And it hasn't been that long that we've been doing this sort of stuff. So there's been a number of things that really came up, but in particular, these two books were published in 2000, the first editions of them. And they really changed a bunch of stuff that was going on, and they were doing something that looked very different than what we were otherwise talking about as causation in philosophy. We then have the development of a semantics for causal Bayes nets formal modeling. And in particular, we have this well-defined notion of an intervention. So this is very much the kind of thing that Cartwright was getting at with the effective strategies, or agency as we found it in von Richt, or in people like Price and Menzies, and in some of the psychology literature. But now it's become sort of cleaned up and rendered more formal and precise. So now you can say that not just doing anything counts as an intervention. There's like strict conditions that you have to meet about exogeneity and aerobraking in a system. So it doesn't, even though it's derived from this idea of adding agency of some kind to probabilities in order to get causation, it doesn't carry this baggage of teleology with it that we had before. Still at this point in time entangled with explanation though, so Jim's original version is a theory of causal explanation. Okay, so this enables, there's 4 key moves that I think are enabling the branching out that in hindsight you can sort of date back to starting in 2000. One of them is recognizing that probabilities alone aren't sufficient, but also that there's something there to which they aren't sufficient. So we really did have to become convinced that we were under-describing something important before there was a motivation to add something to the probabilities. Second was this reincorporation of something derived from agency, but sort of rendered less human a bit in its final form. We needed to have some conceptual clarifications around explanation and laws and powers. And actually, I think Bogan and Woodward's distinction between data and phenomena ended up being a really helpful part of this. And then the fourth part that I'll spend a little while talking about is just bracketing or ignoring metaphysical issues around causation. So they were like, we're just not going to talk about it, and that was the solution. And I think that there's both sociological reasons why that happened, and there were sort of 2 very important people in deciding this is how we were going to do it, one of whom was Clark Gleamore, and the other of whom was Jim Woodward. And Jim was just like not interested, I think. Like other people can talk about that if they would like to, but I don't want to. Whereas I think Clark Gleamore was much more enforcing of that, like, no, really, get out of the room if you're going to talk about that. And so the Reichenbach came back. So in this sense, it's weird because I think it was actually really important to branching off that you just weren't allowed to talk about metaphysics for a while. So I think there's a bunch of, this is the, sorry. As soon as I put the New Hope thing up, I had to go with it. This is the causal exclusion problem diagram, and I can tell you why it's wrong in Q&A if you'd like to hear. But there's a bunch of these problems that seemed really important in the other kind of metaphysics, and they really baked in these unspoken assumptions that were standing in the way of making progress. So a bunch of this stuff had to be just sort of completely ignored in order to make progress in the kind of formal causal modeling that we did. So this is now the sidebar that I added. Let's see. I think that both pragmatism and logical empiricism were born from some really similar motivations. And it was interesting to listen yesterday and hear how similar some of those were. They were really looking at the same kinds of like neo-Hegelian metaphysics and the sort of sharp divide between people doing philosophy and people doing science, and they didn't want that. They really had a sort of emphasis on testability, on meaning in use, and the importance of practice in determining meaning. And they shared this kind of idea, both that there's a sociality about science and communities performing science, while also being concerned about like distorting factors. So in the United States, both James and Dewey especially were really concerned about like both class-based issues and Jim Crow era laws. And so they were trying to use it in the context of a democratic project, whereas the Vienna Circle people were also really concerned about this rising tide of fascism. So I think they had this kind of thing in common. At the same time, the logical empiricists really wanted to reject anything even remotely metaphysical, whereas pragmatism, they reject a bunch of metaphysics, and then James immediately goes on and says, but here's how we should do metaphysics better. So here's a method that we should use for doing pragmatic metaphysics. And they had a very different view of experience. So I think William James' background as a psychologist really plays a huge role in the richness of his view of experience, such that making a difference to it is very different than the view that you get from the logical empiricists. All right, so the M is back. This one's for Otto Neurath. So the upshot is that if you're looking to do some sort of foundations for causation, I don't think the post-Lewisian version of metaphysics is going to help. But I do think this pragmatist tradition offers a really good way to sort of do metaphysical foundations. And I was also struck by the fact that the person I originally learned pragmatism from was Rescher, who is also just like straight up in the, I don't know, logical empiricist tradition. Okay. So I think we've reached the end of how far we can go by bracketing metaphysical considerations. In discussions with people at my own university in like the biomedical physiology department, they have somebody whose supervisor wrote one of the textbooks in causal modeling, and she cannot get her colleagues to adopt it because, as they put it, we really don't know what causation is. Like, we really don't know what we're attributing to something when we say there's a causal relationship here. They also think that the software package is smooth and lovely, and that makes them suspicious because they're like, well, but we couldn't tell if we were getting bad results. So we don't understand causation well enough. We have to really like understand what's going on underneath the hood, as somebody said, not for the software package, but for causation. Like, what is it such that we could robustly verify it some other way when we get an answer that we're not sure about? And so my claim here is that essentially to finish this process of branching off, we have to have some foundations in place. And these can be sort of raft-style foundations, but they need to be the sort of thing that can then help people launch the project of doing causation without having to come back to philosophy every time. All right, so there's some examples, and I'm just going to go through and get to one final part. So I think that part of what's been standing in the way is that we need to figure out kind of how to connect these interventionist counterfactuals to something physical in the world. But it's very easy to accidentally do that in an overly simplified way. So I have sort of two analogies. One that I've heard people say, well, you know, like interventionism writes these checks, but still you have to go to the bank and cash it. What's the physical process that's going on there? And I think that's the overly simplistic way of thinking about it. Because when you go to the bank with a single check, you have to have that single amount right there. There's a kind of like one-to-one going on right there. I think a better way of thinking about it is that part of the foundations involve connecting the physicality of causation to these interventionist counterfactuals in a way that shows you how to support them, that's more like having a monetary reserve for a currency. Like, you should not be going to that if you're cashing a check. Like, you've done something really wrong if that's what's happening while you're cashing a check. But in some sense, it has to be there to ensure that the whole system works. So this is what I think the role of causal foundations is that it is the part that once you really sort of put it in place, it kind of goes out of focus and nobody looks at it again until you're like, well, crap, it's maybe time for a revolution or something in a while. Yeah. And I have a lot more things to talk about, but I want to make sure that we have some time for Q&A. So I do think that philosophy still has this final role to play in establishing causation as this independent science. And this is going to be really valuable because there's causal claims made across a huge number of fields that have more in common with each other, but they don't have the vocabulary to discuss it with each other yet. So I think that this is part of what we can do. I think these historical parallels can be a helpful guide for how we can do a better job than we might have done in the past. And this does give practitioners something that they don't currently have. If they really start having foundational issues, they need to have some foundation that they can go to and use to sort that out. Part of this is the conceptual articulation and refinement, and metaphysics has to play a role in this. So I was, I don't know, raised in a department where at the time you were not allowed to say the word metaphysics, or they would like kick you out and make you go across the hall. I was in Pitt HPS, and they're like, no, that's over there in philosophy. And since then, they've sort of eased up a little bit about it. But I really think that part of what they were reacting to was like the pragmatist, a certain way of doing metaphysics. And I think there's other ways of doing it. So I think there's a lot of exciting work happening there. And because of this, I've been thinking, oh, we should start having like departments of this or something like that. All right, so that's the, yeah, that's it.
Okay, we have time for a couple questions. Start here.
Hi, thanks. That's a lot of material. My question is really about Chang's epistemic iteration, because I don't quite see the analogy with what you're doing, because as I understand it, what he has is it's when you know what to make of a move in a physical sense in a laboratory or something, you know, like how are you going to define temperature next or something like that, you know. And I don't see that in your story that there's any physical change going on. It's more a conceptual change or something. Mm-hmm. And I don't know. It was just hard for me to see that as an epistemic iteration, even though I kind of see your idea that we're converging on something. But could you say a little more about that?
Yeah, well, and some of it's apologies, because I got very excited about the stuff I could say on this topic, and it was in the parts that I skipped over. So the last section where I think we're actually making progress right now, I think is sort of a clearer example of epistemic iteration. And I don't think epistemic iteration just has to be for physical measurements, but I do think it's also for physical measurements in this particular case. So part of what's happening is there's been back and forth around, for example, the causal faithfulness condition is a requirement that you might have to make certain kinds of assumptions that you don't have like exactly canceling out causal effects. So if this, you know, if one cause brings about an effect with exactly the same strength with which it cancels it out or suppresses it via a different path, then they'll look like they're independent of each other, and that's a violation of causal faithfulness. And so then you have this really interesting sort of very pragmatist perspective on what you do then, because part of what you want to do is, you know, okay, what are the systems in which this should happen? It's clearly not analytically true that everything with causation has to have this feature. Are there weaker versions of causal faithfulness that we can have? And then in that case, what inferences can we draw? Yeah, and so there was some stuff also, for a while there were people really excited to put grounding and causation together, and you can do that if you like ruin causation. You have to give up the causal Markov condition, and I'm like, no, but then like you can't make any inferences. And they're like, yeah, but then you only have one relation instead of two. And I'm like, oh, but if you had two, you could make all of these lovely inferences because causation behaves more consistently and homogeneously when you don't lump it together. And I feel like we're at the stage of like, okay, under what circumstances should we say that the causal Markov holds or fails to hold? Are we better off deciding to give it up and then lump this together over here? Or are we better off keeping it here, and then what inferences does it support? So I do feel like we're at this fine-tuning stage. And I think that it's really important to do this conceptual, like, do we have to redo a definition of it another time to make it a little bit more precise? It's kind of like when you make those IKEA bookshelves and you put everything together with like the wooden pegs, but now you have to, like, that's where we're at, is with the wooden pegs, and you have to go through and like actually put in the screws and then tighten them progressively.
Thanks, Holly. A similarly hazardous metaphysical history is in probability, of course, from early years to Laplace. Is this an analogous case where the mathematicians sort of bracketed all that, like Kolmogorov and measure theorists and so on, and then, well, it's not like the problems went away. There's still refinement and interpretation of probability. You know, mathematicians get on with applying it, but there's still room to understand what we're doing more from an interpretive perspective.
Yeah, that's an interesting question because I think the interpretation of mathematics is a different case because you're using it for so many different things. And so somebody earlier today was talking about how the content to which you're applying something should be reflected in the way in which you're talking about it. And I would be inclined to do that. I have a colleague who does she does straight up ersatzdism about possible worlds, and we try and talk about this stuff. And she's really outraged at the idea that I think probability is just things that obey certain sets of axioms. Anything to which I can apply it effectively counts, because she has this very much narrower metaphysical view of it. So I would have to look into that, but I think it would be sort of almost at cross purposes, because they were trying to do something independently of physical interpretation in a way that here we're trying to get into the physical. Does that make sense? Yeah, so I think that, yeah, it would be interesting to look into.
Okay, we've got one last question.
Oh, hi, Ollie. Thank you. This is wonderful. So just shortly, your case was Newtonian mechanics and how it kind of developed out of natural philosophy. I was just wondering what your thoughts are about maybe like statistics or something, because causation seems like a methodology which is used across sciences rather than having like a ambit of its own. So
yeah,
have you looked at how statistics got its own disciplinary identity, even though it's used in lots of different ways in lots of different sciences? Perfect.
Yeah, so that's a really excellent question, and there's actually a paper that a former graduate student of mine has on exactly that point. And so I don't know if he has it available, because last I heard he hadn't sent it off. It was one of these HPS papers where he'd been looking at early statistics, including Wright, and I can't remember the other guy, and they were really, really close to coming up with causation. And then there was some really weird thing involving guinea pig reproduction that made him decide not to do it that way. So they had this really interesting, so his name is Zili Dong, and he's just graduated, I think, from Western, but he has a paper on this. And it's a really interesting case of how they almost got there, but not quite. And so they went with statistics instead of what could have been causal analysis at that time. And so I think statistics is an interesting case because I think what they're doing is sort of different than the causal modeling stuff, because a lot of people know how to do statistics, but also would like something in addition to it. And so I think that it's like statistics, you're right, in the sense that it would be across different fields, even while the way in which it's applied. So in biomedical physiology, you're going to have a lot of systems that just intrinsically violate causal faithfulness because they all have evolved homeostatic mechanisms. But you're not going to have that if you're talking to the people who are doing on induced superconductivity, who will have a totally different set of problems. And so in that sense, I think there will be some things that are common across those different settings, such that they would find it illuminating to see what that common cause, or what that common sort of underlying set of techniques and assumptions are.
Right.
Okay.